Since we are through with factoring polynomials, today we have a new lesson, and this is all about rational algebraic expressions. Let us now use Module 3.1, Journey in the Islands of the Philippines. We will start with the definition of rational algebraic expression. When we say rational expression or rational algebraic expression, or what we call algebraic fraction, it is an algebraic expression in the form of P over Q, where P and Q are polynomials and Q is not equal to 0. From this form, P is the numerator, Q is the denominator. P and Q should be both polynomials, and the denominator Q must not be equal to 0. So, we have these examples under rational expressions and examples for non-rational expressions. Let us start with 4 over 3. 4 and 3 are positive numbers, and these are also considered polynomials. So, both 4 and 3 are polynomials. These are constants or considered as monomial. Next, 7x, numerator, denominator is 5y. 7x is a monomial over 5y, which is also a monomial. Another example, our numerator this time is a binomial, x squared minus 1. The denominator is also a binomial, x cubed minus 3. For the last example, numerator and denominator are also polynomials. What kind of polynomial is this? With 3 terms, we have a trinomial in the numerator and a binomial in the denominator. Now, what about the non-rational expressions? We look at this example, 4 over the square root of x. This is non-rational because of the denominator. Although 4 is considered as polynomial, but the square root of x is not a polynomial, it is a radical number. The next example, 3x minus 5, the numerator is a polynomial, but the denominator is 0. Now, the condition for rational algebraic expressions, the denominator q must not be equal to 0 because this is meaningless, and this is called undefined. Let us answer activity 1. In activity 1, we have 3 columns. Let us solve for the value of each exponential form. First, we have 2 raised to the 4th power. Our base here is positive 2, exponent is 4. How will you solve for the value of 2 raised to the 4th power? You just multiply the base itself 4 times. So that we have 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Therefore, 2 to the 4th power is 16. How about 2 to the 3rd power? The same base. How many 2's do we have now? There should be 3 2's. It is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Okay, next, the same base, we have 2, exponent this time is 2. So 2 squared or 2 raised to the 2nd power is equivalent to 2 times 2, and that is positive 4. 2 to the 1st power, if the exponent is 1, then the value is the base itself. How about if the exponent is 0? Any base, any number, any variable for the base, if the exponent is 0, the value is always equivalent to positive 1. The base is equivalent to 1. Next, so here we have negative exponents. Now, to rewrite this into positive expression, we make this as your denominator. Since 2 raised to negative 1, denominator is understood to be 1. Getting the reciprocal, we make this as your denominator. Numerator will become 1. And then with positive exponent, that is positive 1. So this is 1/2. So 2 raised to negative 1 is equivalent to 1/2 or 1/2. Understood that the exponent of 2 is positive 1. Next, 2 raised to negative 3, the same process. We have numerator is 1, and then denominator is 2, but with positive exponent. Negative 3 will become positive 3. So here you can still simplify the denominator. You retain 1. And then 2 to the third power is 2 times 2 times 2, and that is positive 8. So 2 raised to negative 3 is 1/8. It is a fraction. Okay. Next column. This time our base is 3. For positive exponents, 3 to the fourth power is 3 times 3 times 3 times 3. So multiplying the base by itself 4 times, we have 3 times 3 is 9 times 3, 27 times 3, we have 81. Next, 3 to the third power, 3 times 3 times 3, and that is 27. 3 to the second power, 3 times 3 is 9. And then we have 3 to the first power is equivalent to the base, which is 3. But for 0 exponent, it is always equivalent to 1. And then 3 raised to negative 1, this will become a fraction. 3 will become your denominator with positive 1 as the exponent, and that is 1/3. And 3 raised to the third power should be 1/3 raised to positive 3. And 3 raised to positive 3 is equivalent to 27. Therefore, it is 1/27. Okay, next. How about if the base is a variable? So here we have how many x's? 1, 2, 3, 4. The same base. You add the exponents. 1, 2, 3, 4. Exponent is positive 4. Next. There are 3 x's. Therefore, base is 3. Common base. Add the exponent. That is 1 plus 1 plus 1 is 3. Next. 2 x's. And that is 2 raised to the second power. Then x, or x raised to positive 1. Well, it is also x. X to the 0 is 1. And then next we have x raised to negative 1. We have a fraction that is 1 over x raised to positive 1 or 1 over x. And the last one we have 1 over x raised to positive 3. So this is activity 1. We can also evaluate rational algebraic expressions. Like for example, in activity 2, we have the following rational expressions. Number 1, a over b squared. The values of the variables are given wherein a is positive 3, b is positive 6. Now, what is now the value of these rational algebraic expressions given the values of the variables? So, we will use substitution method. We will substitute the values of a and b in the given expressions. So, our solution will be, we have a, 3, replacing 3 in terms of a in the numerator. Therefore, we have 3 over b is 6. And that is squared. And then retain the numerator, that is 3. Then simplify 6 to the second power. This is 6 times 6. And 6 times 6 is 36. Now, you can still get the lowest term. What is the lowest term of 3 over 36? You divide both numerator and denominator by the greatest common factor. Greatest common factor is 3. So, divide 3 by 3. So, we will divide this by 3 over 3 to get the lowest term. Therefore, the lowest term is 1 over 36 divided by 3 is 12. So, we have 1 over 12 for number 1. Next, number 3. For number 3, 5x squared over 8y. When x is equal to 0, y is equal to 11. The same process by substitution. Bring down y. 5x squared means 5 times the value of x, but x is 0. Then you square 0. Then for the denominator, we have 8 times the value of y, which is 11. 0 squared is 0. Times 5 is also 0. Then 8 times 11 is 88. Now 0 divided by 88 is still 0. Next, number 4. Our variables are E and F. When E is negative 6, F is positive 5. What is now the value of these algebraic expressions? We will substitute negative 6 in terms of E. Bring down 3. Then we will multiply this by the value of E, which is negative 6. And then bring down 4 minus the value of F. We will square F. But F is 5. And that is 5 squared. Then simplify. What is 3 times negative 6? Negative 18. How about the denominator? We bring down 4. Then minus the square of 5. 5 times 5 is 25. Therefore, we have negative 18 over, what is 4 minus 25? Subtract. Sign of the bigger number is negative. So, it should be negative 25 minus 4 is 21. Okay, you can still get the lowest term. Lowest term, negative, divide the sign. Simplify the sign. Negative divided by negative is positive. So, quotient will become positive. Then, what is the greatest common factor of 18 and 21? What number can be divided into both, to both 18 and 21? By 3. 18 divided by 3 is, you divide 18 by 3. So, we will divide this by 3 over 3. You get the lowest term. So, negative 18, or rather, negative divided by negative is positive. So, the value should be positive because of the same signs. 18 divided by 3 is 6. Positive 6. And 21 divided by 3 is 7. So, the answer is 6 over 7. Last example. G plus 6 over 2h minus 3. This time, G is equivalent to negative 2. H is positive 2. So, by substitution, we will change G to negative 2. Bring down 6. Bring down 2. Multiply 2 by the value of H, which is 2. Then minus 3. Negative 2 plus 6. Again, different signs, subtract. Then get the sign of the bigger number, that is 4. 6 minus 2 is 4. Sign of 6 is positive, so that is positive 4. 2 times 2, we have 4. 4 minus 3. So this time we have 4 over 1, or 4. So these are the answers for activity 2. Next activity. For activity 3, you match column A with column B by determining the value of the variable that will make the expression meaningless or undefined. So it has something to do with the denominator. Denominator must not be equal to 0. If the denominator is 0, then the expression is meaningless or undefined. So we will look for the value of the variable in the denominator. So number 1. For number 1, we have 4 over z. What will be the value of z that will make this expression undefined? Since z or z is a monomial, if denominator is a monomial, understood that the value of z is 0. That will make 4 over z undefined. So here, z is 0. Next, so where is 0? Letter C. So our answer is letter Z. That is 0. Next, number 2. Solution for number 2, we have 5 over x plus 6. Our denominator is x plus 6. Let us equate x plus 6 to 0. So for x plus 6, the denominator, we will equate this to 0. And then we will transfer 6 to the right, or we will transpose 6. Then change the sign. It will change the sign. Therefore, to solve for the equation, we have x equals negative 6. So where is negative 6? Letter A. Next, number 3. Our given is a minus 7 all over a plus 4. Our denominator is a plus 4. Again, we will equate this to 0. Then transposing positive 4. So we bring down a to get the value of a. Just transpose 4. This will change the sign, and that is negative 4. So, letter D. And then number 4, we have m over m minus 12. The same process, we need the denominator. Equating the denominator to 0. Then solve for the equation. M is understood to be positive 12. So where is positive 12? Letter E. And then the last one, number 5. The denominator in number 5 is n squared minus 1. How will you solve for the value of n that will make this undefined? You will equate the denominator n squared minus 1 to 0. Transposing negative 1 to the right, we have n squared equals positive 1. And then to cancel the exponent, get the square root of both sides. 1 is a perfect square. Cancel 2. This will become n. The square root of n squared is n. The square root of 1 is also 1. So for number 5, we have positive 1. And that is letter B. And this is activity 3. Okay, for activity, or rather for assessment card, that is only multiple choice. So let's proceed to enrichment card. For enrichment card, we evaluate the following expressions. First expression, quantity x minus 1 close quantity raised to negative 2. How will you evaluate this if x is positive 2? Then for the second expression, y raised to negative 3 minus y raised to negative 2. Evaluate where y is positive 2. Okay. For number 1, we will change x to positive 2. Therefore, we have quantity 2 minus 1 close quantity raised to the second power. Next, simplify the numbers inside the parentheses. What is 2 minus 1? 2 minus 1 is 1. So So, what is 1 raised to negative 2? So, since our exponent is negative, you have to make this positive. How? 2 raised to negative 2 is equivalent to 1 over 1 raised to positive 2. And therefore, we have numerator is 1. Denominator is 1 times 1 is also 1. 1 divided by 1 is still 1. So the answer is 1. Next, number 2. Y is positive 2. Therefore, we have positive 2 raised to negative 3 minus positive 2 raised to negative 2. Okay. Let us express these two positive expression. We have now 2 raised to negative 3 is equivalent to 1 over 2 raised to positive 3. So again, to make the exponent positive, you make this as the denominator. Then just simply change the sign of the exponent. And then minus. This can also be 1 over 2 raised to positive 2. Then simplify the denominator. Retain 1 as your numerator. 2 raised to the third power is 2 times 2 times 2, and that's 8. And minus 1 over 2 squared is 4. Now, how will we subtract this? Get the LCD. LCD of 8 and 4 is 8. What is 8? Divide by 8 is 1 times 1, we have 1. And minus 8 divided by 4 is 2 times 1 is 2. So therefore we have 1 minus 2 is negative 1. And denominator for LCD is 8. So the answer is negative 1 over 8. See you tomorrow. We will discuss the next lesson tomorrow.